Thank you for the kind invitation to talk about the mineral resources of Sweden to the Master's Program in Sustainable Development at Uppsala University. My name is Magnus Johansson. I'm a senior geologist at the SGU, the Geological Survey of Sweden, but I've been previously working as a consultant and also in the industry. My field of work has been very wide range of geoscience areas covering physical planning, raw material supply, quaternary geology, industrial minerals, you name it. Sweden has been well known for mining since the Middle Ages, and internationally, if you ask someone about Sweden and mining, they are usually say it's about iron. And if you refer to languages of other countries, you might even find words there. For example, in Germany, you'll find the term Schwedenstahl, referring to high quality steel made out of Swedish iron ore, a quality stamp for the Swedish mining products. But Sweden is also much more than iron. We have a lot of other very interesting minerals and resources in our bedrock. If you have a look on this map, you'll find the iron ore production throughout the world. You'll find the big players here, Australia and Brazil, but also Malmberget and Kirunavaara mines of Sweden up in the north. We're a fairly small country by international measure, but still stand out on this map. And the situation has been the same for the last years. We've had a continuous all-time high for the Swedish iron production. Near 40 million tons of iron ore and close to 50 million tons of non-ferrous ores have been mined each year throughout the last years. And as I said, Sweden is still a global player of quite small size. By European measure, we account for more than 90% of this European iron production, and also a considerable amount of the EU base metals, silver, and gold production. Despite this, Swedish mineral resources have much more to offer, especially if you look for technology critical minerals or technology critical elements, as you sometimes say, the TCEs. In this talk, I'm going to speak about the geological setting, the mining sector, the mineral resources, but I'll also have an outlook on the future potential. I'll also discuss two examples on recent exploration projects for the TCEs, the technology critical elements. If you look at the geological setting, Sweden differs from Central and Southern Europe. In brown and red here, we have the Proterozoic and Archean rocks of Fennoscandian Shield tectonic plate. It's a quite old crystalline bedrock, more than 2 billion years, and it's a remnant of a Sweco-Karelian orogeny. In lighter color, you'll find the younger Sweco-Norwegian orogeny of southwest Sweden and southern Norway. It's about 1 billion years old crystalline basement, much younger than the eastern part, but still quite old. Together, these two domains comprise some 79% of Swedish territory. In light blue, you'll find the Phanerozoic sedimentary cover rocks that were deposited on top of this ancient crust. They are of Ordovician to Tertiary age. You'll find them on the islands of Gotland, Öland, in southernmost Sweden, in Skåne. But if you look inland, you'll find erosional remnants in the regions of Västergötland and also up in around the lake Siljan in Dalarna. These are, as I said, erosional remnants. The sedimentary layers once covered large parts of Sweden, but today comprises only 4% of Swedish territory. They are made out of volcanics, sandstone, alum shale, limestone, marl, clay, even coal. Last but not least, you have the early to mid-Paleozoic, some 500 to 400 million years, Caledonian orogeny, comprising folded and thrusted crystalline and sedimentary rocks. Rocks that were placed in an ocean between our continent Baltica and the continent of America with Greenland. And this, today you'll find it in the mountain range between Sweden and Norway, created in this collision of the continents. You'll find the same rocks in Scotland also, and in the Appalachian Mountains, as well as eastern Greenland, of course. This area makes out some 17% of Swedish territory. And then, of course, you will have the quaternary cover from the ice ages, moraine, sand, clays, covering very large parts of Scandinavia and Sweden. When mining started, for bronze, you'll need copper and tin. Later on, you recognized iron ore and learned how to handle it. Very early also the noble metals were of interest. The base metals were added. And this knowledge of mining and the ores has been imported from Central Europe for Sweden. The knowledge and technology, and you'll find this also in technical terms adopted from German language in Swedish, if it's about mining technology or the work done in a mine or the mining constructions. And for Sweden, mining has had a huge impact on state finances, as well as Swedish industry development over time, and through this also facilitated the society as we know it today, with our wealth as we have it in Sweden. Sweden has about 3,000 historic mines. The vast majority are in the region of Bergslagen, as you'll see on the map on the left. The timescale below shows operation time for selected mines. There you'll find the iron ore mines, the actives in blue, the non-actives in green, and the other ores, noble metals and base metals, active in red, inactive in orange. But some of these operations also are intermittent. For example, in Kaunisvaara, the mine started 2012, closed 2 years later, but reopened in 2017 and is today still operating. Also, if you look at Dannemora, it's a current application to reopen the mine because the ore is still there, and mine closure is often made by fluctuations in the world market prices, for example. If we look into some of these old mines, we've got the Falun copper mine. It's documented from the 12th century. Its heyday was in the 17th century, where in times Falun accounted for 2/3 of the world copper production. Mine closure was in 1992. Main commodity was, of course, copper, but also other sulfide ores, zinc, lead, bismuth, silver, and gold. The last years of operation, there was also a sulfur production. The byproduct is the Falu red paint, the very well known for Sweden. You'll also find the Garpenberg mine. It's documented from the 13th century. It's active today. It's run by Boliden. They are mining sulfide ores also, zinc, lead, silver, and it is a skarn deposit. That is, you have the ores associated with carbonate rocks, in this case dolomite. Then you'll have the Sala silver mine. It's been documented from the late 14th century. It was very rich silver ore, and the heyday was the 16th century, where up to 5 tons of silver was mined each year, financing the Swedish Empire of that age. Mine closure was in 1908, but started again in periods. For example, in the crisis of the First and Second World War, when Sweden had to depend on the resources found within our borders, since the blockade of the war was hindering all transports, exports, imports. Today at this place we have a limestone mine operating, producing industrial mineral. At the Sala mine, besides the silver, they also produced lead and zinc, so very often you have more than one product at a mine. Many mines in this area, called Bergslagen, closed in the steel and energy crisis of the 1970s. In this map, you'll find the primary mining regions of Sweden. The map shows a location of active mines by the large dots, and the assets of mineral deposits in Sweden are primarily situated in these 3 mining districts where all active mines are located. You find the Norrbotten field up in the very north. You'll find the Skellefteå field. You'll find the Bergslagen area. But you'll also look on the map, you notice there are small widespread dots all over Sweden. They mark location of other known mineral deposits. The current state of the Swedish mining industry. We have some 12 active mines and in addition one inactive where gold ore is processed and enriched. LKAB has 3 mines, Kiruna, Malmberget and Svappavaara up in the very north. Boliden runs 6 mines. Aitik in the north, Garpenberg in Bergslagen, but you also have in the Boliden area, the Skellefteå field, several mines of Boliden. Also in the Skellefteå field, you'll find the Mandalay Resources Björkdalsgruvan mine. And if you turn south again, you find Lundin Mining operating Zinkgruvan at Askersund, northeast of the Lake Vättern. You'll find Lovisa-gruvan. It's the smallest mine in Sweden. But also up in the north again, Kaunis Iron with Kaunisvaara iron ore mine. And associated with this mines and mining sites, Sweden has an industry cluster of internationally well-known mining equipment companies, mining technology, tunneling, drilling. And internationally, the Swedish mining has been quite competitive due to high ore grades and also a very high level of automation and using high tech in the production. Challenges at the moment, long permitting processes, you have social licensing, you have the public awareness of the raw material needs. These are all challenges that needs to be addressed. Registered Swedish mineral deposits by million tons of iron, base metals, noble metals, graphite, REEs, and further. In dark orange, you will see the reserves. A reserve is a known mineralization that is profitable to mine. Of course, the distribution matches the previous image where you have the mines. The resources, that is a known mineralization with a reasonably high likelihood for economically viable production. It has not been that extensively investigated, but you know that you have a good deposit, but you will need to prospect more on this to start a mine. Compared to the Swedish map of the last slide, you'll see that there are large unexploited deposits when you look at the mineral resources. Also, one thing to consider in this map is the dimensions of the icons. I said it was size by tonnage, but these are fairly different commodities. Deposits such as REE and battery metals, graphite, may be of much more importance than the size of the symbols indicate. Iron ore may have many tons, but these other special minerals and special metals maybe less ton, but quite high value. We can look into one of these in the south. That is the Norra Kärr deposit. Some of you may have heard this in the news or discussed it elsewhere. Norra Kärr is a rare earth elements deposit, REE. And special about Norra Kärr, it is one of the world's principal heavy REE resources. One of the biggest deposits known. And so far the only deposit of note within Europe. It has a very unusual enrichment in the most critical REEs that are essential for high strength permanent magnets, such as dysprosium, terbium, neodymium, praseodymium. These elements you need to make effective electrical engines, generators, windmills, e-cars. And these are also the heavy REEs, the HREE. And if you look into geology or mineralogy, the definition of Norra Kärr is a per-alkaline layered nepheline cyanide intrusive complex. It's dated some 1.5 billion years ago, placing it belonging to the older Fennoscandian part of the basement. Of course, it's crystalline rock. And this intrusion, to say it in simple geology, it's a basic rock intrusion, a mafic intrusion. Probable reserves as counted for in this project by 20 years life of mine. They have some 23 megatons indicated at 0.59% REE and a total of 17 megatons of waste rock. And to talk about this, if you compare it to windmill, it might need some 350 kilos of neodymium and other REEs to make it work. And the day pit, as it is supposed to be here, would measure, you see it in the picture on the right, some 900 by 400 meters and 150 meters deep. There you also find the reason for the big amount of waste rock, because you need to have space on the sides to be able to excavate all the ore you need. So that will create the side rock or the waste rock. In this case, they have planned 25 hectares total area for infrastructure connected to the mine. Enriching process was planned to be acid leaching on site, like Talvivaara in Finland, and this is also a concern for many, or was a concern. You can compare with the Talvivaara dam breach in 2012, was also a big headline. 2013, the company gained a 25-year exploitation permit. It was granted, but then reverted to application status by a Supreme Court verdict in 2016. The main concerns were Natura 2000 assessment and tailings and water quality. Since then, the company has done a new plan for this site, and the acid leaching process will be done at the smelter. So on this very place near Gränna on the eastern side of Lake Vättern, they plan to have the crushing, grinding, and enriching, but not the acid leaching. At the moment, the application is pending. They are working on the environmental assets and planning for gaining the permissions. But permission, well, it's still unclear if they will gain it. Many of these new discoveries are TCEs, the technology critical elements, such as REE and battery metals. Demand is rising, and also the Northvolt startup in the north by Skellefteå is pushing exploration and development. Everyone wants to buy an e-car, and we buy or build windmills. This is pushing the demand. Many new of these REE discoveries, for example, are made in old mining areas where reworking of old tailings can be evaluated. Sometimes it's also greenfield projects in areas that have not been mined before. The REEs, they can be of quite different origin. As I said, there are heavy REEs, there are light REEs, and you find them, for example, associated with the apatite iron ore mineralizations in Norrbotten, for example, in Kiruna, as well as in Bergslagen, if you look Grängesberg or regions. You'll find them also in various skarn deposits. Where the skarn was where you have ore associated with carbonate rocks. For example, in Bergslagen, you have the Riddarhytten Norberg belt. You also have hydrothermal deposits. Ulserum and Bastnäs are two examples for that. Or, as I mentioned before, you'll have the alkaline carbonatite basic intrusions such as Norra Kärr complex and Alnö also. If you have a look at the global allocation of exploration costs, you'll find many big players here. Australia was big in mining, Canada, US, South America, Russia also there, China. But still, you find Sweden placed on the map. And compared to the rest of the world, the mineral exploration in the rather small country of Sweden is still notable. And think of that the land area of Sweden is 0.3% of the world land area. But still, we have Sweden appearing on this map. If you take into consideration of all commodities, not just the iron, as on this map, Sweden has near 4% of global prospecting cost. This is more than 10 times the size of Sweden. And the reason is geology. Sweden has a quite special and ancient bedrock hosting a lot of minerals and metals. And if we look into criticality of different raw materials, I mentioned this critical materials. The EU Commission released a report last year with an interesting picture. In this picture, you'll find criticality defined from low in green up to red with a high criticality on the left side. And if you look carefully there, you'll find the red section is the HREE and the LREE, the heavy and the light rare earth elements. And in decreasing scale, you'll find a number of other critical elements. 2011, the EU Commission published a list of these critical materials. They named 11 different. 2020, the list contained 30 materials. At the moment, they are amending the list with further materials. And what is then critical? Occurrence, area of use, access demand on the market. The definition here is goods of economic and strategic importance with a high supply risk. The European Union uses today 25% of the world production of these materials, but only produces 1/10 of what we need, some 2–3% of the world production. The supply risk depends on how many countries can deliver a commodity and what kind of countries they are. Are they reliable traders? Can we depend on them, or will they use the raw materials to put political pressure on us? These are discussions arising through the Ukraine war, about Russia, about China, about dependence, about raw materials pricing. And if you look also on this image, of course, you'll find what we need for the green transition, as are highly dependent on these most critical raw materials, the REEs. They are in the e-mobility, in the engines, generators, windmills. You find them everywhere. On this map, you'll find the global production of CRMs. Quite catchy is the situation. Who is the biggest producer? China. By far. Totally dominating the REE market. You'll also find Canada, USA, Brazil, Australia are big players. South Africa also. Some countries are especially well known for one material. If you look at Central Africa, you'll find Congo producing some 70% of the world cobalt production. Cobalt is essential for if you want to make batteries. So it's very important for any kind of phone or e-car or whatever you need to make. But Congo is also a very unstable country. There have been wars, there are conflicts. If you compare social security system, insurance, environmental legislation, and such things, it's not the best place, perhaps. At least not if you compare to Sweden or other European countries. This might also add for China. How stable is that country? How well can you depend on China delivering these metals that we so badly need? Also, if you look at Russia, you find you'll find that they are very big on the platina group metals, supplying a large part of the world market with that. Ukraine is also a relevant producer of REEs. And with the ongoing war and blockades, this is quite relevant questions. Where do we source our materials? How can we guarantee that we can access them to a relevant pricing that is fair enough, but also that we are fair enough in sense of how it is produced environmentally, socially, and also notable, all the maps I've shown you so far, there you have found Sweden. But if you dig into this map, you'll find a circle over Scandinavia, but it's not of Sweden. We don't have any RE production here. We don't have the critical raw materials production yet. Norway and Finland do, but Sweden is still one of the EU countries with the highest geological potential to start up production. On this map, you'll find the present exploration permits, green applied and red granted, the shown on the map. The diagram shows application for mineral prospecting in Sweden over the last 20 years. You see there are ups and downs. The curve shows significant indents from the financial crisis in 2008, but also fluctuations because of ore prices on the world market. They also have a very big influence. As you have seen, there are many known deposits in Sweden, but Sweden is still very underexplored. There is a high potential to re-evaluate old abandoned mining areas with a new perspective, looking for new resources or new elements that were not previously known there or mined there. And also outside of these areas, of course, there is a high potential of finding new deposits. But it's most within the crystalline bedrock, the very old basement bedrock. But still, we also have other deposits here. We do have metal enriched organic shales of early Ordovician age, and they might be of quite big economic significance. Historically, these rocks, these sedimentary rocks, have been used for extraction of potassium aluminum sulfate, alum or alun in Swedish. They've been used as fuel for lime burning because of the high organic content. Because of that, they have also been used as raw materials for petroleum production especially in the Second World War, when we could not import. And there has also been a short period of uranium mining. These alum shales are today used in Estonia and other countries for energy production. And today in Sweden, we have alum shales as exploration targets at several places, both in the mountain range next to Norway, as well as in the south. But here the focus is not energy, but other interests. We'll dig into the Scania alum shale deposit. It's an exploration project of a vanadium and battery metal deposit in South Sweden. This deposit, it's a TCE deposit of vanadium and battery metals, all on the critical list. Host rock is the organic shale of Phanerozoic sedimentary cover deposited on the old Fennoscandian crystalline shield. This permit is some 220 square kilometers of prospecting area. They had field work and drilling ongoing. Target was to identify some 1,200 million tons of ore with 0.5 to 0.8% vanadium oxide. In addition, other metals were beneficial in this. They had a JORC mineral resource classification, that is a certified way of accounting for the resources found. It was some 117 megatons of 0.4 V2O5 indicated and inferred. And that at that time they had less than 2% of the license area explored up to that date. They planned this operation. It's in East Skåne in southernmost Sweden, in Österlen. It's an agricultural area. And the mine operation was planned to be subsurface mining, as not to obstruct or destroy the landscape, not to stop the present land use. Problems here have been public acceptance, fear of impact. Landowners have been very active against the project, refusing to accept it. It's been a big discussion in media, pro and contra. And also one problem of this project is that the Scandinavian alum shale generally has some uranium content. These grades are very low, but of course you can extract and use the uranium. And you need uranium for various civil applications within X-ray or medicine. But of course you can also use it as a fuel for bombs or even for energy production in a nuclear plant, as you know. And this political decision to ban uranium mining in Sweden affects usability of many relevant TCE deposits. And I mentioned earlier, it's seldom that you have one element that you mine. You often mine many together because it's the special mineral association and they appear together. Of course, if you can extract them all, you get more economic value out of the production, more use of the rock that you mine. But in this case, it may cause, this uranium ban may cause environmental problems and high cost, because you must extract it from the rock you mine together with the other ores and metal that you extract. But if extracted, the uranium at the moment must be disposed as waste without being used, without being sold. And that, of course, is a high cost for the producer, for the miner, but also for the society, creates a problem because we are creating a waste dump of something that could be used instead. So it's a dilemma. And at the moment, this project is on hold. The big discussion about this area and the project has led to a halt in this prospecting. And at the moment, there is no ongoing work here. The presentation has now reached the home straight, and I'll summarize Sweden's mineral resources as a SWOT analysis or SWOT diagram of strengths, weaknesses, opportunities, and threats. If we look into the strengths, you'll find Swedish bedrock is variegated and very rich on mineral resources. Sweden has technology and experience. We have strict environmental and health and safety legislation governing any industrial production or mining production, as well as the society. But there are also weaknesses. It's time consuming and very costly to go into the application processes for mining. And this ties up the financial resources from all the investors. You have quite unpredictable permitting processes, and that may cause high financial risks for venture capital. That this makes it less interesting to invest in these projects. This is also reflected in the Policy Perception Index of Fraser Institute. It's kind of index of how well accepted these projects are in the society and how well they are going. And Sweden has been dropping quite a lot in recent years. Finland and Ireland are, on the other hand, good examples on the top places on this index, showing that they are very attractive to invest in these countries. Also, the political ban on uranium mining may also hamper exploitation of TCE deposits. Opportunities. Of course, Sweden is very rich on the critical raw materials, the TCEs, as of REE, battery metals, and whatever. We have a very high potential on new exploration findings, and we also have a very relevant potential to play a strategic role in the EU raw material supply chain. Potential threats, that's areas like social licensing, geology and mining industry in public perception, and the public awareness of raw material demands in our society. Sometimes you'd say that there is an unawareness of raw materials. You don't know where you get the materials from. You don't know what you need. And that is also a reason for low acceptance. My presentation is now nearly finished. I've talked about different aspects of mineral resources of Sweden. The geological setting. We have a setting differing from most of Europe, South and Central Europe. Sweden and Scandinavia has ancient bedrock. Talked about the mining sector. It's diverse. It's very high tech in Sweden. We have very strong industry clusters here. I've talked about the mineral resources. They are rich and manifold. They are of significant importance and strategic value for the EU. And we also have the future potential here. Unused registered reserves, new discoveries, We have a change of focus to the TCEs, REE and battery metals. But politics and public perception plays a very big role if this can be used. This lecture has been supported by the EIT Raw Materials at Schools project. Next week, at the next lecture, there will be time for any questions related to the presentation. Thank you for your attention.